explain this a little bit. So we're asked to find the perimeter of the region. We need the arc length plus the 2 radii. So to find the arc length, that was L was arc length over circumference is equal to the arc measure over 360. And we found the arc measure by doing 360 minus 115. That gave me this central angle of 245. And we know that the central angle is the same as the arc measure. So 245 goes here. Our radius is 5.3. And then what I'm going to do is, in my calculator here, I'm just going to multiply this out. Notice my answers are all in decimals, so I'm going to use the pi button. Don't use 3.14, as we talked about in the video. That isn't as accurate as the pi button in your calculator. So my circumference is 33.3008. I'm going to take the entire thing, and I'm not going to round until I get to my final answer. So then I'm going to cross multiply. I'm going to take this answer that's already in my calculator, times it by 245, and then divide by 360. So that will give me an arc length of 22.663. Now, that's not my answer though, right? And a lot of people saw that and probably said A right away. That's not the answer because that's just the distance around the perimeter. What I need to do is I need to also include both radii. So if this is the arc length in yellow, then I have to add both radii to that. So if I add 5.3 plus 5.3, that's 10.6. So if I take 10.6, we get 33.263 feet. And that is the full distance around the arc plus both radii. Okay, so hopefully that helped answer maybe one of the questions that we had from the quiz. I promised a couple people we would do one more quick little explanation. I'm not going to do the exact quiz itself, but I'm going to take a problem similar to that. And you'll notice if quick, I just cloned these two. And let's say that I tell you that triangle ABC and RST. So ABC is similar to RST. Okay, that's given. And then I also give you a couple other things. I tell you that the side length here is 5 inches and the area of this shape is 15 inches squared. Okay. And then on this one, I tell you that the area here is 7.5 inches squared. And I tell you to find the length ST. All right. Now, this might not be exactly, I'm trying to remember if this was exactly the same setup as the quiz. I think it was. But what do we know? They gave us the two areas. So I know that the ratio of the areas, which is a squared over b squared, that has to equal. Now here they don't tell me which direction to go, so I'm going to start with AB first. That's 15 over 17.5. 7.5. Now what I would do here is I would try to reduce this in my calculator. This is not the friendliest problem. You guys had a friendlier problem, but I do know that that reduces down to 2 over 1. Okay, now that's what a squared b squared is equal to right here. What I want then, I want to find a side length. And if I'm looking to compare side lengths are the ratio of just a to b. So I need to do something to this a squared over b squared to make it a over b. Well, the thing that we do to get rid of the square roots squared, we're going to square root every side. So the square root of a squared is a. The square root of b squared is b. And then here, the square root of 2, the square root of 2 does not reduce down. And the square root of 1, well, the square root of 1 is 1. Well, okay, what does that tell me now? My pen is screwing up. Hold on. This now is the ratio of the sides. So I had the ratio of areas. Right? That's the ratio of areas. I want to use the ratio of sides. So I'm going to use this square root 2 over 2, and I'm going to compare that to the side length of CB, which is 5, compared to the side length of TS, which is X. And now, this is how I'm going to solve. So what do? We cross multiply. 1 times 5 is 5. And if I cross multiply the other way, I get the square root of 2 times x. And this, like I said before, this is not super friendly. I believe the one on the test was friendlier. But then I have to divide by the square root of 2. And you could say x is equal to 5 square roots of 2 in this case. Or, as we learned, we don't love having that square root of 2 on the bottom, so they would turn this into 5 root 2 over 2, and that's what x would be equal to. So that is just a quick little explanation of the problem that was probably the most missed on the quiz. It was this one and a problem like this. So here's the nice thing about today. If you felt comfortable with finding arc length, just right here, maybe you got tricked on the two radii being added together, but if you could find the arc length successfully, then I think you're going to think today is very friendly because it's almost the same thing. The only difference is now instead of finding the arc length of this portion of the circle, now I'm going to ask you to find the area of this sector. Well, area is in the same ratio as the central angle over 360. The only difference is instead of area over circumference, we're going to do the area of the sector over the area of the entire circle. So technically, the only thing that changes today is instead of circumference, it's area. All right, so I really like this quote. It's never too late to be what you might have been, meaning it's never too late to start trying. And that's a perfect example for where we're at right now in geometry. We had talked about, and this is really important, if you've mastered chapter 11, which is what we're currently in, if you have done very well in area, the next unit, chapter 12, is going to be pretty successful for you because it's really based off of all the stuff we're doing in this unit. If you are struggling with this unit and you do not come and get help, then you are going to struggle even more in chapter 12. So come seek me out if you have questions, and we can talk about it. All right, so today is section 11.5, and it's called Area of Circles and Sectors. So hopefully you don't have to write this whole thing down, but you definitely need to know that the area of a circle is pi r squared. And some of you like the circle song. If you haven't watched it, type in circle song into YouTube and go watch it sometime. But it's a nice way just to sing a song about the difference between area of a circle and circumference. Okay? You do have to know circumference is the distance around, and that's 2 pi r or pi d. The area is the amount of space that this circle would take up, and its formula is pi times radius squared. All right, so we're not going to get too crazy into that. If you know the radius or the diameter, you can quickly find this answer. So what I'd like you to do is I want you to try a shaded area problem. I want you to find the area of this dark shaded unit if you know that these are congruent circles. Okay, so I'll give you a couple minutes on this. We're going to go over it, and my hint to you is leave pi as your answer. Don't use your calculator. Try to get what we call an exact answer. So I'll give you about 3 minutes on this. And so what I want to do here is our goal is to find the area of the dark shaded region. I would recommend, just like we did before with other shapes, set up your shaded area problem or your picture equation. So, well, what is the shaded area? The shaded area is the big overall circle that was completely shaded in. And then what did we do? We took away the area of two circles, but these are congruent circles, so I can find the area of one of them and times it by 2. So what does that mean? All I need then is I need the radius of the big circle and I need the radius of the small circle. So I'm a fan of just kind of writing the formulas out. We know that the area of a circle is pi r squared, and I'm going to subtract 2 times the area of the smaller circle. Now I should be really careful. This r and this r are 2 different radii, right? The small circle has a radius of 3. So I can do that pretty quickly. I'll plug 3 in, and I get 3 squared is 9. 9 times 2 gives me 18 pi. So notice leaving pi makes this really friendly, and we don't have to deal with decimals. So then the question, and the challenge maybe, is what is the radius of the big circle? Right? How long is it from there? Well, notice if I go from the center out, that's the radius, but this length is the same as this length right here. So this length is the diameter of the small circle, which we know is double the radius, which is 6, so 3 and 3, which means that is the radius of the big circle. So the big circle has a radius of 6. And then I know pi r squared, well, 6 squared is 36. And then you can think of pi as the same as a variable, right? 36 pi's minus 18 pi's tells me my shaded region, the shaded area, is equal to 18 pi. And then my units are meters, so we're going to put meters squared because it's area. And this is what we talked about as an exact answer, meaning you leave pi in there. You don't have to times by the pi button to get decimals. A lot of times it's really convenient, like this problem, just to leave it as pi. Okay? All right. Now comes the new material for today. Now we've talked about, actually we haven't really talked about this idea of a sector. This is kind of the first time that we've officially defined it. We may have seen portions of the circle before, but a sector is considered part of the circle, right? And it's part of the circle that is bounded by 2 radii and the intercepted arc. Okay? Some people like to think of this as a piece of pie. So I would definitely write this down since it's a new vocabulary piece. And as you can see here, we have one sector that's shaded in blue, but we also have another sector, right? We have the second piece because by definition, this region out here is also a sector. It's bounded by an arc and both radii. And some people like to think of that as like Pac-Man. Sectors are Pac-Man in a sense. So the big question of the day is, how do I find the area of this? Well, we're going to set this up before I even show you the theorem, because my guess is you probably already know. We do know the radius, and we know we have a central angle. And if I call this AB, maybe I'll randomly put point C here. But we know the radius, we can find the central angle, which means we can find the arc measure. So how do I find the area of the sector? Well, the area of the sector, when compared to the area of the whole circle, which is pi r squared, that ratio, how much space this blue one takes up compared to the whole area, has to be the same as the measure of the arc AB as it is to 360 degrees. So notice it's almost the same thing as what we did on Monday. The only difference is we're finding the area of the sector, and it's over the area of the circle. And that's the big piece that you have to remember, is that down here, this is pi r squared, area of the circle. And I'm going to put area of the entire circle, because sometimes students just forget that when we say pi r squared, this is the area of the entire circle. So technically, that's the area of the sector. Here's what it means in words. If you want to write it down in words, you can, but that's how I would find the area of the blue sector. So what do you need? If you have the radius and you have the central angle, then you know the area of the circle, or you find that out, and then you know the arc measure. All that's left is cross multiplying to find the area of the sector. And we'll do this in pieces. Find the area of both sectors. So you got the yellow and the green. And I want to do this together just because you might notice there's a really fast way to do the second part. So if I find the yellow one first, there's a fast way to do the green one. I'll give you a second. Go ahead and draw this. If you have colors, you can color it in. Otherwise, maybe just shade the yellow one and leave the green one blank. We're going to focus on the area of the yellow sector first. So what I would like to do is area of the yellow sector. Now, we usually don't have a variable for, like with arc length, we had L. We could use A here, it's up to you. But I'm just going to say area of the yellow sector over the area of the entire circle. So that's pi r squared, and we know the radius is 12. And that has to equal the arc measure from A to B, which is the same as the central angle. So 100 degrees over 360. Now let's find the exact answer here. So we just get practice with that. So when I do that, I'm going to calculate the entire area of the circle is 12 squared times pi, or we're going to call that 144 pi. And then we're going to multiply that by 100. So I'll get a pretty big number. And then we're going to cross multiply. And let's just call this A for now. So I get 360 times A, and we just know that A is the area of the yellow circle. And then divide. Divide by 360. Now, the hint here is we're not going to use the pi button, right? We're just going to leave pi as pi. So I'm going to take 100 and, what is that, 14,400 divided by 360, and we'll get 40. So what does that tell us? What do we know? We know area of the yellow sector is 40 pi, and then they didn't give me units. It's 12, but it's not anything special, so I'm still going to include the units as 12, excuse me, 40 pi units squared. And that's the area of the yellow sector. Now I hinted at this. Find the area of the green sector. You could probably do this in less than 3 seconds. And I might have you do that right now. Can you put in the chat, what do you think the area of the green sector is? And you can do this to a private chat. And if you want it, instead of the pi, put PI for pi. Send me a private chat on what you think the green sector is. If you know it. Mm-hmm. So let's talk about this. So let's think about this. Well, wait a minute. Pi r squared. This right here, 144 pi, was the entire circle, right? That's the area for the entire circle. Well, 40 of those pi's are being taken up right here. That means that the remaining 104 pi's units squared has to be for the green, because together the green and the yellow have to add up to give me the entire thing. So a very quick way of finding another sector is looking at the work that you already did to identify the area of the full circle and subtract. And there you go. 104 units, or pi units squared. Okay. All right, so another style of question here is to find the area of a region that looks like this. Now, notice they don't tell you anything special. They just say, here's my region. They do give us a couple of hints, though. So we have to find the area of the region. This is what we call a composite solid, which we haven't talked a ton about that. And I used that word wrong. It's a composite shape. A solid would represent 3 dimensions. So this is a 2-dimensional shape, but it's made up of a square, a rectangle, and then part of a circle. And the part we have to discover is the fact that, ooh, wait a minute, this is a straight line. Linear pairs. We haven't used that term in a long time, right? If this is 90, then this is 90. And we could also make the conclusion here that These are congruent. So the only difficulty in this is finding the area of this portion. And there's a couple ways to do it. Some people might say, well, wait a minute, isn't this just a fourth of a circle? So can't I just do pi r squared times a fourth? And you're right, you can. It's also considered a sector. And I could do 90 over 360, which, by the way, is a fourth. So we'll talk about that. I'll give you a second to, why don't you try this problem, see how far you can get, and we'll go over it in about 2 minutes. So let's find the area of this region. I'm going to do it in chunks. The first one here, we've got a square. So I can go 3.5 times 3.5, which gives me an area of 12.25 units squared. And then the area of the rectangle base times height. 7.2 times 3.5 is 25.2 units squared. So those are pretty quick. And now there's like we said, there's a couple ways to do this one. And I really don't care what approach you take as long as you show your work so I can see what you're thinking. I'm going to do it as if it was the area of a sector. Okay, so I'm going to call it area of the sector. That's what we're trying to find. Over pi times r squared is equal to the central angle, or the arc measure, which we know is 90, out of 360. Now, if you just did the area of a circle times a fourth, if you reduce 90 over 360, that's where the 1/4 comes from. And this might be friendly. Maybe I'll show you this. So notice 90 over 360 reduces down to 1/4. And what I could do, if I'm finding the area of the sector, I could times, instead of dividing by the area of the circle, I could times by the area of the circle over here. So you can kind of see why these two are the same. Instead of cross multiplying, I just times everything over here. However you want to view it. And then since these are decimals, I'm just going to take and use the pi button here and get its decimal. If you did the exact answer, that is fine as well. But I know the area of this sector rounded to 3 decimal spots is 9.621. And then my final answer is adding up all of those areas. And somewhere just mentioning the total area is the sum of those 3 pieces. So nothing super crazy. It's just, again, using the area of a sector formula to help us find the area of portions of a circle. We got one more. This one's, actually we got 2 more, but this one is one more we're going to do together. And this might be the hardest that this style of problem can get. So I remember this being on a test a couple of years ago, and it was one of the ones that our students really struggled with. So let's pause for a moment so you can draw this and just kind of, instead of writing this, you could include the information in here if you need it. But our goal is to find the area of the circle segment. So that is this red shaded area. All right, so our picture equation is going to be the red shaded area. Well, how do I find that? Well, what is it? Picture, what if the entire sector was shaded in? So what if I had the sector of the circle that was completely shaded in like this? And then what are we doing to it? We are cutting out, so we're subtracting the area of that white triangle. So those are my two things. I need to find the area of the big sector, which shouldn't be too horrible. And then I need to find the area of the triangle, which might be a little more challenging. So I'm going to kind of set off and do some side work down here. So let's think of this sector and let's actually analyze what do we have. I know that the measure of angle A is 130. So its arc measure is also 130. So I know that I'll have 130 over 360, and we want the area of the circle, which is 2 times pi times r. But I don't know the radius. I'm going to have to find that. The only thing I do know is I know that this length from B to C is 40. So we have to get a little creative here with finding how we do this. And this is the part that is a little tricky. Something you can always do is you can draw a radius in this way, right? And why is that important? I purposely drew this radii in so it bisected this segment. And then it also bisects this angle. So now each one of these small angles is going to be half the value. So this will be 65 degrees, and this will be 65 degrees. Notice 65 plus 65 is 130, so we still are holding true to everything. And because we cut BC in half, that's 20, and that's 20. So to find the radius, I actually have to do even more side work. Let's draw one of those small triangles. Let's draw this triangle right here off to the side. Here's my radius. It's a right triangle. We know that this length is 20. And this length, this angle measure is 60 degrees, 65 degrees. Well, we now have to find the radius. And we're given the opposite and the hypotenuse. So even more side work, we're using our good old friend SOHCAHTOA, which means the sine of the angle measure, right, the sine of 65 is equal to the ratio of the opposite over the hypotenuse. And in this case, we call the hypotenuse r because that's why we're doing all this work. And sine is opposite over hypotenuse, so we can cross multiply. I get 20 times 1 equals r times the sine of 65. But then I would divide by the sine of 65. And then let my calculator do the work from there. So if you haven't changed your calculator at all, it should still be in degrees mode. But if you share it with a friend or a sibling, double check, hit the mode button, make sure you're in degrees because we're doing sine of 65. And then do 20 divided by the sine of 65. And on this one, we can round it to 3 decimal spots. 22.068. So double check your calculations. If you did this exactly and you didn't get this answer, that means you're in the wrong mode. All right, so all of that work allowed me to find the radius, and I clearly did not leave myself enough room to put in that number. And actually, I actually put the wrong thing down there, so good thing I had to check that. We're doing the area of the red segment, and that's pi r squared. I accidentally put a 2 here before. I did exactly what I told you guys not to do. So pi r squared is the area of the entire circle. And then I'll just call this a red A because that'll be the area. So then we're just going to use your calculator. We're already dealing with decimals, so use the pi button. And we're just going to cross multiply. I'm going to multiply these two together and then divide by 360. Right, so you don't have to show, all I need to see is this setup. You can do the rest in your calculator because I'll know that you cross multiplied the area of the circle times 130 and divided by 360 to get this. That's why it's important to show how an equation is set up. All right, so that was a lot of work just to find the area of the red sector as if it was completely shaded in. Right? If all of this sector was shaded in, it would be this right here. So the next thing I need to do is I need to find the area of the triangle. Well, I know area is 1/2 base times height. Unfortunately, this is not a 90-degree angle, so we can't just do a base and a height, which means I'm going to draw this triangle and we need to know the base, which we do know, right? That base is 40 from B to C. Then I have to find this height. Well, wait a minute. Isn't the height just the other value that we needed over here? So I'm going to call this, I'll call it X. I'm not going to use H because I don't want H to be confused with the hypotenuse. So now I either need to take my answer from the radius and do Pythagorean theorem, or since it's already set up, let's just do SOHCAHTOA here. The X value is in the adjacent, and I could use my answer. I could use opposite over adjacent. I could use tangent, which is what I'm going to do. Or I could use cosine with the X over the hypotenuse because we now know what the radius is. I would recommend using the tangent ratio though. So it's tangent of 65 degrees is equal to the ratio of the adjacent, which is X, over the, opposite over adjacent. Opposite over adjacent, so 20 over X. And then same thing, we're going to cross multiply and solve. So I'll get 20 times 1 equals x times tangent of 65, and then just divide 20 by the tangent of 65. And that will be x, which is the height that we need. Okay. So you should have got 9.362 rounded accurately to 3 decimals. And I know my base is 40. Base doesn't mean bottom, right? Base is where the height and the other side length meet. And then the height is the 9.326 that we just found. So I know half of 40 is 20. 20 times 9.326 is 186.523. So we found the area of the triangle. We found the area of the red sector. Now we just have to subtract them. So you can see why we did this problem. We wanted to review SOHCAHTOA, right? That's what made this problem challenging. And then my final answer, whatever these two are, subtracted. And they don't give us units, so area of that little red sliver is 365.935. I will say this is definitely not drawn to scale. So just so you're thinking about that. So let me show you what I got. We'll go through these very quickly. So if the diameter is 16, that means the radius is 8. Find the area. 8 squared is 64. And then leave our answer in terms of pi. So it would be 64 pi feet squared is number 1. Okay. Number 2, they give us the circumference is 22 pi. So I'm going to take 22 pi, equal it to 2 pi r, because that's the equation for circumference. I'll divide by 2 pi, and I get 11. 11 is my radius. Now I'm going to use that radius to find the area. So 11 squared is 121 pi, and they want our answer in terms of pi. So I get 121 pi meters squared. All right, and then the last one, this is the work that I had done, is I took the area of the sector over the area of the circle, and the radius is 6, equals 106 over 360. And then I found the area of the circle, 36 pi, and I times it by 106. And then I divided by 360. And then I actually read the directions, so I got 10.6 pi is the area of this sector, but it said round to the nearest hundredth. So on Delta Math, you're going to have to do that, and you got to be careful. Use the pi button and then round to the nearest hundredth. So this case, it's the second decimal. So your answer should have been 33.30. If you round to 3 decimal spots, that's the thousandth place. All right. So these notes will be posted shortly after lunch. You can go back and check them if you need to. Your homework tonight. So remember, the first part was 11.4. That's what you had to do on Monday. Today, you're going to go back to that assignment and do the second part, area of the circle, circumference, and area of the sector. And then the last question says, did you submit this to Schoology? This is officially due tomorrow at 3. All right, that's all I have. If you did not finish the quiz from yesterday, please do that. If you need help, I'll be available in my office hours. Have a great day.